Hi, this is Ian Buckley and you are watching MakeUseOf.com. Today we'll be getting started with Zode.io and Arduino. Zode.io is a visual programming language which allows you to create quite complex code for Arduino without needing to know how to do that code. This is a sponsored video, but all of the opinions you hear today are completely my own. So, what is a visual programming language? Well, it just simply means that you don't have to actually do the code. You build your program yourself using nodes that are already provided in the program. There are more nodes getting added all the time. Zode is in fact an open source project, which means that many people in the community are already adding their own nodes. They're helping with bug fixing. You don't actually have to know code in order to create your own node. You can do that in the IDE as well. The setup to it is similar in some ways to things like Scratch or ArduBlock if you've used them. Again, users of Macs or Node-RED might see some familiar things. And to get started, the quickest way is just to click the Get Started Now button and create an account. Once you've done that, you will land in the Web IDE. And this is a fully functional version of the IDE. The only difference between the Web IDE and the offline IDE that I know of is that you can't actually deploy directly to an Arduino. So let's say you have actually made your code and then you wanted to deploy it. It will give you a message that you need to download and open the desktop version of the IDE. However, if you only have the online version available to you and you do still have a way of deploying to Arduino, there's nothing to stop you simply clicking Show Code for Arduino, and that will allow you to see the transpiled code, and you can copy this into the Arduino IDE and upload it, and that should work just as well. So, we're going to start today by going through all of the different elements of Zode.io and how they work, and we'll be doing this in the desktop version, so if you haven't already, click Upload to Arduino and just click Download. That will take you directly to the download page for the Zode IDE. When you open the Zode IDE for the first time, this is what you'll see. This is the Welcome to Zode project that opens on your first time using the IDE, and it is a great resource for learning. It's the only thing I've looked at to learn this. I quickly went through this example project, which has so far 29, but as you can see, I'm assuming they're going to add quite a lot more to this. Different ways in which you can use Zode. The tutorial goes up in complexity, so it's a very good way to get familiar with it. The main pane here is called the patch window, and this is where you will build your patches. This is where you will make your programs visually. There's already an LED node in here, and if you click on the LED mode, you will see the inspector window in the bottom left just here. Now, every single node has its inspector, and there are always values which you can change directly. So, for example, I'm just going to say port 13, because that would be the onboard LED for an Arduino Uno, and that's what we'll be using today. So let's just say Uno onboard for its name, and as you can see, it updates. And then the LUM value, which I presume stands for luminosity, that's something you can affect again directly. Or if you did have another node, you can connect these nodes together. That's something we'll cover a little bit later when we make an example project. On the right-hand side of the IDE, there is a quick help menu, which is contextual. So if you click on the LED node we've already have in place, it tells you how the LED node works. It also gives you information about the inputs and outputs that the node expects. You can also find this information in the project browser. So if you collapse the Welcome to Zode project and open up the hardware menu, this is where the LED node can be found. So if we have LED selected in this menu, you can open the help menu by clicking on the context menu or simply pressing H. And that will show you the same information as over here. And if you want to place it, again, you can click place, or you can simply drag and drop it into your project. It's worth mentioning at this point that a shortcut that will save you a lot of time when you are using Zode is either pressing the I key, which opens up the search nodes menu, or simply double-clicking somewhere in the menu. This is a lot faster than digging through all the menus. Of course, if you're using something very specific, you might need to dig in there, but if I just wanted to get a button node, for example, I can just type node into the button menu, double-click, and it will give me a node for a button. So to get a rough idea of the workflow in Zode, we're going to create a blank patch by clicking on the Add Patch button. I'm going to call this LED Nano, as I have an Arduino Nano board attached to my computer currently. And I'm going to start at the end. This is going to be a very simple patch just to show how it works. We'll do something slightly more complicated in a moment, but it's always good to start by thinking what your end product shall be. In this case, what I want is for the onboard LED on the Nano to turn on. So I'm going to double click down here in the patch window, which brings up the node searcher, search for LED, and open it up. And here it is. We have our LED node, and it's always a good idea to give it its own name. So here in the inspector, I'm just going to say this is Nano on board. The port number for the onboard LED is number 13. And this luminescence value, we could change it right now. We could change that to 1, upload this to the board, and it would work. It would turn the LED on. But it doesn't really show how these nodes work. So what I'm going to do is I'm going to simulate a button press. If we did have a button attached to it, I can get the button node out to show you. You can see on the right here that if we had a button attached, we could say which port the button was attached to. We could say how fast we want that to update. But the important thing is what this node outputs, which is a boolean value. A boolean is true or false. For the purposes of this program, it's always worth thinking that a boolean is true or false. It's also the same as high or low or 0 and 1. If you were to plug this button directly into the luminance value of the LED, this would work perfectly fine. And every single time the boolean was true, the LED would be on. When it was false, it would be off. And it would happen instantly because it updates continuously. Now, let's say you don't have a button next to you, but you do want to learn how that would work. You can simulate this. This outputs a Boolean value. So let's try something else. Let's say if we just wanted a Boolean value to test, there's a lot of things here, but the one that you want is constant Boolean. This gives you a constant value, which you can change in the inspector. So I'm just going to call this my bool, and the value we want it to have is true. Now you connect them just by clicking and dragging, as you saw me do with the other one. However, the input pin can only have one link. That's because we already have this button that we're now not going to use attached to it. So if you've made a link that you don't want anymore, you just click on that link line and press delete, and it will go. And now we are free to attach our boolean to the onboard LED. So this LED node and this button, which isn't really a button, are now ready to go. Let's deploy it to the Arduino. Under the deploy menu, if you click upload to Arduino, you will notice that there is a big list of all the different Arduinos and various other things that you can use. At the minute, it's mostly Arduinos. I do know that they have plans for having other boards natively supported in the future. That's also something the community is working on. And much like in the Arduino IDE, you can select your COM port here. I'm going to leave the debugging and the compiling in the cloud part out of this particular tutorial, just simply because it's not necessary for a beginner. But if you do know what those mean, then you'll be very happy to see that they are there. The compiling in the cloud option seems kind of awesome. But for today, we've got everything we need to, so I'm just going to upload this to the Arduino Nano, and as you will see when I do it, it will cause the LED on the Arduino to turn on. One quick point before moving on, when it comes to deployment, you can always deploy through the deployment menu, but there is also this small lightning bolt symbol in the bottom right which you can use to deploy. And if you expand this menu, you can actually see the log of the deployment. This is also where you find some extra tools such as the debugger, but we're not going to go into that today. So now that we've seen a basic implementation of Zode, let's do something slightly more complicated. So once again, we're going to create a new patch. I'm just going to call this one test 2. And as you can see on the screen right now, I have an Arduino Uno, which is attached to a servo and a RGB LED, along with a potentiometer. So here in Zode, we can start putting this together. Let's start at the end. We know we're going to want a servo. So I'm going to double click and search for the servo node, open it up. And in the inspector, we can see that we can define its port number, which is going to be pin number 9 on our Arduino. And I'm just going to call this one small servo. On the right hand side of the screen, you'll see that once again it has this little help context menu which tells you the port number. We've seen that before, and it also tells you the value, which we've used before, but this is quite interesting in that the servos in Zode are mapped between values of 0 and 1. This is just for convenience, I think. It certainly helps in this project because, again, potentiometers are mapped between 0 and 1. Just worth knowing, we're not going to be using it today, but if you do need it, there is actually in the Zode core a map function which will map things to each other. So you don't have to use the given values that they have, but I just thought it was worth mentioning that they've been standardized, which makes it somewhat easier. So let's add an LED node for our RGB LED, and I'm just going to call this RGB LED and change it to the correct port, which is 11. And I shall add one more for our onboard LED, which is port number 13. So now let's think about the input side. We know we want a potentiometer, so once again, I'm just going to press the I button to bring up the search and just search for pot. And under the common hardware of Zode, they have a potentiometer node, and once again you can see this is similar to the button we looked at before in that it has a port. You can determine how often it updates, and it also has a value that it spits out. So we have it already attached to analog 0, so we can leave that as 0. We want it to update continuously, and we want its value to be the same value of the servo and the RGB LED. Now, I'm not going to put it straight to the onboard LED because what I want to happen is for this to turn on when the potentiometer is halfway up. And we can't do that directly because this potentiometer will spit out from 0 to 1, and the onboard LED will only turn on when it gets a 1 or a high or a boolean true value, as we've seen before. We can get around this by using one of the inbuilt nodes that already exists, called the greater node. Now, the greater node does more or less what you'd expect. It has two values, and if one of the values becomes greater than the other, then it will output a boolean. So, for our second value, I'm going to change this to 0.5, and I'm going to connect the potentiometer value into the first value here. This means that whenever the value from the potentiometer becomes higher than 0.5, it will output a boolean value. And as we've seen before, these boolean values, when they are false, it is the same as 0 or off for the LED, and when they are true, it is the same as on. So now, with this in mind, if we upload this to the Arduino, we should find out that it will be working as we would expect it to do without having to do any code. So I'm going to do one final check through just to make sure I've given them all the correct port numbers, and I'm going to use this button to deploy it to our Arduino. So as you can see, in quite a short amount of time, you can put together code visually that will do the same job as something that might have taken you quite a long time to get your head around if you were a beginner. Now, that's not to say that it isn't worth learning code as a beginner, but the convenience of doing it this way cannot be overstated. From my point of view, I think this will be most beneficial to me when I want to put something hardware together and prototype it quickly. I can't think of something that I would want to prototype that I couldn't actually quickly work out in Zode first. And if there were more complicated things that I would need to put in it, there's nothing to stop me creating my own nodes in order to do that. By the admission of the Zode developers, it is a young project. It's something they say on their website. And considering this is something that is just in its beginning stages, it's already quite impressive. As I mentioned, I can't really think of anything I would want to do that I couldn't do in Zode quicker than with the Arduino IDE. That doesn't mean it is limitless, but in the short amount of time I've been using it, I certainly haven't come across any problems that I would have been able to solve easier using the Arduino IDE. Alongside the library that comes with the IDE in general, there is a section on their website for extra libraries that have been made by people in the community. And not only that, there is a forum which is full of people who are taking on Node and taking on Zode and starting to use it and get behind the Node way of making programs. So Zode is by no means the first IDE to take this approach. As I mentioned at the start, there are similarities to be had, certainly with things like Max or Node-RED. Maybe people that have used Scratch in the past or Arduino will see some similarities there. But for something that's just starting out, I found this a really easy thing to use. And although I haven't had the chance to check them out fully yet, they do have their own YouTube channel, which takes you through some tutorials as well, which I would check out if I was you. So this has been a very early look at Zode.io. I am impressed. I like it. As I mentioned, I'm probably going to use it. If you want to do it yourself, as I mentioned at the start, it's very easy. Just head to Zode.io, click Getting Started Now, and you can start using it in the browser. And as soon as you have an Arduino set up, you can use the desktop IDE in order to make projects that way. But I hope this gave you a good idea of what Zode is all about. I'll certainly be looking into it more in the future. I hope you guys do too. Let us know in the comments below if you're going to use Zode, and don't forget to subscribe to makeuseof.com for more weekly tech tips and giveaways. Cheers.